Hey, it's Phil here. I'm planning on trying something a little bit different today, and you can let me know whether you like it or not. Um, so, what I wanted to talk about today is the layers that you should expect to find in a tiered application. Um, and what we're going to do is we're going to start quite coarse, and then we're going to narrow down, and hopefully this is useful to you. So I think probably getting right into it, what people, particularly non-technical types, how they often experience an application is just basically via the user interface. And so you might have a set of controls, with a set of controls in here that people get used to, and I think it's good if you have a set of patterns that people, your users start to find familiar. But more than anything else, if you have things in your front end which represent objects, it's good if people can interact with those as though they are an object in itself. And I think one of the mistakes that people can make when designing software is they think a lot about data and less about the things. Maybe that's the right choice for your particular use case, but a lot of the time I think that it makes a lot of sense for your users to be able to talk about a thing and interact with a thing. So quite often we have a page for getting at the thing, and you can see the details of the object, special properties, and quite often these things are broken down into property pages or tabs, or some other sort of categories that you can break down. If it's a complex object, it'll have lists, or sometimes a tree, and in some cases, it might be complicated to get to the object, and you sort of have a list of, or a tree of objects, which then you can select from that and get to that. But that may be how your most sort of tech-averse users experience your application, but most of your users will have a sort of an idea of your application that there is some stuff that they interact with on the screen, but it's not the real stuff. The real stuff is in a data store that is hidden from their view. And so they know that they have a thing, we're talking about a thing here, and somewhere behind what they can see there is a thing. Storage. And they sort of, this might not be a database, it might be a file. And we talked about the repository pattern last time, and how you can sort of abstract things and how to get them in your application. But I think, the majority of your, barely tech savvy users will sort of experience your application in this way. There's a user interface which you interact with, and they expect that there is some data stored behind there. And for some people, that can be quite a thin, they'll expect it to be quite a thin veil. Now, often as a software developer, you're faced with people that understand your software in that way, but also you need to communicate somehow that in between there is some other stuff. And that might be abstract. Just letting people know that we don't just connect to the database. There are some other things in there. Oftentimes, I think that the less of the information about the stuff you share with your users, the better. But some of the time, particularly if you're dealing with product people, the sort of the business representatives of the users, they will at least need to understand that there are complexities in dealing with getting from here to here. So I'm going to, that's vague. We're going to try and drill into that in a little bit more detail. Some of the time, and I'm just going to move this stuff out the way, because we can think of this as being the presentation layer, and this will be a layer within your front end. And sometimes it is not the only layer in your front end, perhaps. And I'm just going to start drawing boxes here to back and make that a little bit tidier. This is going to be dotted, and this is going to go to the top, and we're going to call it the front end. So we've got a presentation layer, and we may have a little bit of front end business logic. And well, what goes in here? I mean, I think that anything that's interactive needs to go in this layer, and sometimes we will have representations of the business objects. And basically you want anything that you need to deal with in near real time. For example, if you're on a page and you enter something that is invalid into a field, quite often you will want to know about it before you click the save button. And a good way of doing that is to have the information that you need to answer that question right there, and not have to go to the database or whatever other plumbing is involved to get at that information. Does that make sense? Okay. So this is the front end. So think of this as a desktop application, or perhaps a website or something like that. Web page, single page app, maybe a mobile phone application. You've got stuff that you deploy directly to the device that is going to be running it. And in the case of a website, that might be a little bit complicated. You have some static stuff that you deliver off your content management system, like the scripts and the CSS files and maybe your index, but also there will be some potentially some stuff that's running in the front end that's not specifically presentation. Maybe it's JavaScript and representations of the objects that live on the presentation side, so that the page can be interactive without having to hit the back end. All right. So we would sometimes call this a client. All right. So I'm just going to try and squish this up a little bit further, just so that we've got a little bit more space on the page. And, that's a little bit messy, but I'm just going to tidy it up. There we are. And what we're going to put in next is the server. So, you could think of this as an API backend. And this could take more than one form. So what's really What's very popular nowadays is a web backend, and that is quite often deployed to one of the cloud providers, like the likes of AWS or Azure, or IBM Cloud, or even Alibaba. Or you might have this living in a data center, or it might just be somewhere on the network, and the client has to be on the network to get to that, and that's perfectly okay. I mean, I think I'm not going to judge anybody for building things that fit the constraints of their their business solution, but I'm just going to try and describe in general what are the parts that are in there. So quite often we will need an API endpoint. And what does that look like? Well, I write a lot of .NET nowadays, and in the application world of .NET, in .NET Core and the older .NET, we use ASP.NET Core, and quite often as we use a concept called a controller, which is sort of, it's adjusted its meaning over time. Like, I think that it originally came from the Smalltalk controller, which was nothing like what we have here as a controller, but it's an API endpoint. I don't write a lot of Java, but I believe that there's another thing that you use if you're using Java, and if you're writing your own HTTP endpoint, well, probably you would have a TCP listener, and inside the listener it will have some sort of demultiplexer, which takes the requests and turns them into things that happen inside of the application. It has to parse the HTTP transport, the request, and quite often you'll have framework that does that for you. But somehow you will want to take that request that you've received and do something with it. And sometimes there is business logic. And quite a lot of the time there is also something, so somehow you'll need to get to something in the data store. So you've got things storage here, we've got another thing stored here, and what the business logic, well, I mean, I think that in addition to the business logic, you'll quite often usually have another layer here which knows how to talk to the database, and that might be, some people call it a data access layer, some people call it an ORM, and so that's quite a technical term, but it's quite popular to have a framework that will look at this thing and turn it into objects that you can use directly in your language of choice, or take this thing and turn it into tables that you can then store in your data store, or some other mechanism. And the idea with that is that if you've got one of these things, that you don't need to write the other, and it saves you some effort, which sometimes it does. Sometimes you end up leaky abstractions, and sometimes you end up finding yourself down a rabbit warren trying to understand what is happening inside the plumbing of this, and then finally realize that actually you made a mistake somehow configuring it, and it has exposed the details underneath. All right, so that's pretty basic. Sometimes the business logic it is in the form of business objects, so and can you see that this thing, and there might be some overlap between these two things, and so one of the decisions you're going to have to make as a software developer is whether or not you share some of that stuff. This thing on the side might have some different constraints and different requirements to the one on this side, and there are layers between here. So, do you actually want to go through the effort of having to share that? I think one of the things that I've often been tempted to do, and I'm going to take that away. Quite often you have a wire format here in between. Wire format. And we've talked about HTTP endpoints. What's very common now is a JSON REST object format. So it looks a lot like the thing stored here and this thing here and this thing here, and it's the same here. What is often very tempting to do is to try and share some of these things together, but you inevitably run into the fact that these different things they're trying to do different work. In ORM, it cares about the relationships between different objects. And I'll be, a lot of the time there's no hierarchy there. A business object is very often quite constrained just to the operations that you perform on that object, and is not interested in, associated objects. The wire format needs to be flattened to whichever serialization form you're using. I spoke briefly about JSON just before, and this business object might be really tailored towards front-end activities rather than back-end activities. So it might have more details about the relationships between things, names of stuff, and so on. But so now we've got this other layer here, which is the wire format. And I think one of the difficulties here is, like, if we want to share logic between these different layers, well, we have to share something. We have to share types as well, and that makes things hard. Okay, so we also talked about connecting to the database, and one of the things about an ORM is that you are almost always constrained to having SQL and rectangular result sets. So, it has to be transformed. Your requests, commands, inserts, updates, whatnot, have to be transformed into SQL to get to the database where it'll perform the query. And then whatever result that comes back has to be transformed into rectangular form, which then goes into the ORM. And sometimes it does some extra, decomposition. And then you have to decide whether it's worthwhile mapping things into business objects or whatnot. And in some cases, you'll decide that it's not worthwhile. You just want to map from the ORM to that to the wire format, and that's fine. There's no constraint that means that you have to do extra transformation in your applications if that's not necessary. All right. Well, we talked a little bit about the middle tier, but sometimes it doesn't exist. In some applications, you, instead of having this wire format and this API endpoint and this different set of business objects and stuff, you will just have a fat client, and that looks like this, and this is fine too. But there's some trade-offs to doing this. We talked about being on premises, so you may need. Do you see this this connection here from the ORM through the SQL rectangular result set to your data store? It means that somehow you have to secure this thing, and a good way to do that is to not grant access to anything outside of your organization. So that puts the constraint on you that this client lives on premises, and that's fine if that's if you're using a line of business app that's only ever going to be in the same building as the database, or on the same network as the database. There's no problem with that. But there are still some layers that exist even in that circumstance. All right, getting rid of that one now. Some of the time you might also have more than one API, and what that might look like is that you might need to communicate between the two APIs from time to time, and there is more than one way that you can do that. One of the ways is to have an API client inside of your application, one of your backends, and it will call in via the API endpoint. Whoops. Come here, you. Right. Style curvy. We're going to put some curves in here. And that will have a wire format too. We'll talk a bit about wire format, API client. And it's worth noting that we would also have the same kind of thing here in the client application. API client will call into the endpoint, and it recruits the wire format to be able to do that. Does it make sense? Okay, but that is not the only way that you can do that. Some of the time, you might share a database, and you might communicate with the other client by performing a request to the database. A secret thing, and your other, whoops, I've drawn the wrong line there, it's there, and you might have a secret connection to the database which both of your applications speak. And that's okay. A lot of people frown upon this, but there's one way you can be certain that all of your transactions are processed in order, and that is by having a single central place. So if you need to design a system that does this, there might be more sort of fashionable ways of getting at the problem, but this will certainly solve the problem, and quite often it's a simple way of doing it. All right, another option, and this became very vogue about 10 years ago when I was in a different organization to the one that I'm in, but we might send a message. And I guess the crucial thing about a message as compared to a request is that you are not really expecting an immediate response. In fact, one thing that's almost guaranteed is that messages are going to be treated asynchronously and will go into a queue somewhere. So that doesn't strictly go straight to and I'm going to call that thing a message handler. And this is a queue, or sometimes it might be a broker, which we talked about the plumbing here. There might be some machinations here that we as an application developer you don't have to care about. The message goes somewhere and there are some subscribers. And I think a helpful way of categorizing these messages is, we might have a command, and that's typically addressed to a specific party, that thing will field that message type and do something. And another option is a request. And again, that is typically sent to a single party, but the thing about a request is that you are expecting a response. But the difference between using an API client like an HTTP method call is that, this response or this request, you might not expect a response immediately. It might go into a queue for days, in particular if there is high load. And, this application here, it might need to restart, or you might have a pool of this specific application, like 10 instances of it running. You might fire it off from one instance and it is received by a different instance and is processed, 3 days later, and that's fine. So I'm going to put another message handler here, and we're going to call this a response handler. And I'm just going to move this queue over here because I just want to keep everything together. Make that a little bit tidier and make a little bit more space here. So, we've got our wire format rest. And I think it's probably worth noting that, your API requests, they can be commands, requests, or responses as well. There's no reason why you have to constrain yourself to, sending a request and expecting the response back. Your API response might be a webhook that calls back the other direction, and that's fine as well. Okay, so we've got this command, request, and response, and these things all go via, well, I guess it would be a different queue. One queue for that service and another queue for that service there. And actually this is all backend. So I think I might just call this service thing and service another. Okay, another kind of message that you might send is an event or a notification. Now the thing about an event, which is, and I'm going to move that out of the way too. Wow, it's getting really cluttered in here now. This is offending my sense of order. Okay. Right, now the thing about an event is that you might not know who cares about it, and that's fine as well. So you might send your event from here, and it will go to the broker. And quite often, your broker will have a set of topics that individual things like services and listeners and so on can listen for. And, if they're interested, maybe you have a publish subscribe mechanism on this. Maybe it's a little bit more catered and choreographed than that. But the special thing about the event is that you will fire it from here, and really you don't know who's listening. And another service might be listening and will receive the event in an event handler, which really it's the same kind of thing as the other sort of event. But I think what's different to, yuck, okay, cleaning that up. I think what's different between these different kinds of things is that an event is owned by the publishing application, whereas a command, a request, or a response are owned by the receiving application. Does that make sense? So, this thing owns the kinds of requests that it is expecting to hear, and the kinds of response it's going to return in response to requests. Whereas this object, it owns the kinds of event that it's going to raise. With maybe some exceptions, maybe you've published some events that this thing, if something aggregates a bunch of different events, from a, it might be the single handler for a particular event type. and then you sort of give that away to all of your, I don't know. I mean, I guess that there's no real restriction that it has to be published by this thing. I'm sort of ad-libbing here. But yeah, there is a tendency for the service that publishes an event to own the schema for it and the version. All right, so we've got a lot of stuff on the page. I'm going to try and sum up. In the client, we have a presentation layer, and this is sort of the controls and the pages and the things that the user sees. And basically all of your users will understand what this thing is and what it means. And then, some more of your users will understand that there are more details behind here. You will potentially have some power users that understand that things live in the backend, live in the database, and some will even have access to the database directly so that they can perform queries on that. And those people can be really helpful for doing certain things, and they can also be dangerous. You probably want to control who's allowed to do that. But one of the ways you can do that is to provide some kind of a management interface to this thing. And so there might be a power user interface, like a scripting API, command line tools, something like that, something with a little bit more power, scriptable, like the likes of Excel. You just need to see how many non-programmers are Excel magicians to know that this kind of thing is worthwhile building. And if you're not careful, people will build it in Excel anyway without your assistance. I've definitely seen that happen. But yeah, so what we'll often do is either it will connect to the API, or and I've definitely seen this, it will go straight to the DB. Not advocating for this as a common pattern, but I've definitely seen that happen. Like, not joking about this being an Excel spreadsheet. Okay, so summing up, we have the client, which has a presentation layer, some front-end logic, sometimes an API client which calls into the back end, sometimes it will call directly into the database. We have a service tier, which sometimes will have it will typically have API endpoints that you have to call into. Sometimes there will be business logic, but not all the time. Very often there will be an ORM. On occasion there's not. Sometimes we just have the API endpoint and then writes raw SQL to the back end. And if you're writing something really small, that might be all right. It can certainly go wrong, and there are some poor practices that I've seen out there, like SQL injection. So if you are concatenating SQL strings, be very careful, and I'd urge you to stop it, and instead to use a framework that protects you from certain security violations. You might have a business object in here that encapsulates the same kind of things in here. These things might share some code, and in fact, some of the time this thing, and this thing are the same thing. Some of the time this thing and this thing are the same thing. I guess a fair bit of the time I've also seen some business logic over here in a form of stored procedures. So we're going to call that stored procedure, but actually it's business logic. But I think that it would be unusual to share it with the same of these. I think, I'm no expert on that stuff, but I believe that it's possible in SQL Server to host .NET store procedures, so perhaps you could share some of that stuff. I don't know. Maybe it's worth researching. Okay, we've got the power user interface, which we talked briefly about. We have the wire format that things need to be converted to in order to go on the wire. We have SQL and the tabular data sets that come back. We have events that can go to the broker and are published and subscribed to by other services. We have commands, requests, and responses, which are also messages and that are sent asynchronously and maybe are received asynchronously too. The other service might have all of the same things that we have here, and perhaps it doesn't. This might, in practice, be built in a different language by a different team, in a different building or business, and still share some of the same API logic, perhaps some messages. Somehow you're going to have to communicate with each other about what these things are. Quite often we do that by sending a package. Sometimes you just send a payload format. Same kind of thing with this. The wire format may be built in-house or given to you by a vendor, and you just have to make use of it. Well, I think that's just about everything here. I think I'm at risk of sort of trailing off here. So if you like this, let me know. I'd really love to hear your questions and feedback. And, if you want to contact me, hit me up on email, Threads, Twitter, find my GitHub, or just like and comment below.